Um, just to spread the gossip, I cannot avoid to say that we have ongoing commercial project with Xerox, but please don't ask me what we do inside. They would kill us for that. As a clean technology, I cannot avoid to speak also about the nanoporous carbon aerogel supercapacitor. It is related to fuel cell as well, but here we don't study or model any chemical reaction. We work on development of new material or prediction properties of new materials that could have significant charge capacity and could be used as supercapacitors. That is also in very big demand on the market. For example, if Ken Harris and his group succeeds with creation of solar cells, the next question would be how to store the energy and where to store it. So the answer perhaps could be obtained from studies on nanoporous carbon aerogel supercapacitors. There is something done already in this area. For example, carbon nanoporous material has been studied for the subject of pore size, pore distribution, and other properties to see how big charge can be accumulated in this porous matrix, and also what electrolyte can be more efficient for that purpose. Significant outcomes from that study is that in this system we have several electric double layers. For example, first one can be inside of porous materials, and there is another electric double layer and at the surface of I'm finishing. At the surface of electrolyte, and recently Alterna Biocarbon company demonstrates very significant interest to study in this area. This is a major company in Canada situated in British Columbia. Here they work with biocarbon or biochars, and here I show you micrographs for cellulose and some other components used to generate these nanoporous and microporous materials. Depending on time for how long they are immersed into water, you can create from nanoporous size to some microporous materials as well. And it's very cheap. So instead of conclusion, I would like to reiterate some other ongoing projects in our group. First of all, it's protein hydration and protein drug interaction with direct application in pharmacology. That project we do with our Japanese colleagues, and one particular reason, there are many reasons, but one particular reason is that they are really rich for computational power. We need a lot of computational time on supercomputers, and what of course we have here in Alberta and in British Columbia, but it looks that they have more. Partial molar volume and partial molar compressibility of protein is also related to pharmacological studies. Self-assembly structure and stability of synthetic organic rosette nanotube in solution is creation of new materials. Interaction, aggregation, and slow dynamics of prion proteins in solution has direct relation to Alberta agriculturing, because as you know, Alberta is one of the major producers of beef in the world, and unfortunately cow sometimes becomes sick with prion disease. Molecular theory of liquid interfaces and soft matter has application everywhere, because interfaces and whatever new materials. Nano-engineered chiral thin films for photonic devices and integrated optics and fast gas sensors is related to creation of new devices on nanometer and micrometer scale, and just started new project with another group of Japanese colleagues, multi-scale modeling, synthesis and application of multifunctional gelators multifunctional gelators is their invention, but they would like to know more about the property. That's why we are involved here as a theory and modeling group. And particularly, they can be applied as a solvents for carbon nanotubes, because carbon nanotubes are known to be not very good to be solved in water or other solvents that we have presently on market. That would be all briefly about activity in our group. If you would like to know more, please go to our webpage or ask directly from me, from Sergey, or our group leader. Thank you for your attention.
Thank you very much for an interesting presentation. We have time for one quick question that we would like to ask one. Okay, we'd like to ask one.
How does a company that may be involved in developing a new technology that wants to do some modeling,
Yes.
work with you or Sergey on the development of a model? How would they approach you and discuss this?
We coordinate our efforts. First of all, they they tell us what's the problem, what they want to know, and of course we analyze that. We see if we can use theories and approaches that we already have at hand, or we have to work on extension or even developing on something new. That last case is, I would say, it's rare. Mostly we work on application and extension or combination of different theories on working on different scales, because you can find professionals who have experience to work in one particular area. If they started to solve Boltzmann equations, say in a doctoral level, they continue for ages and even after getting doctoral degree and etc. But and also limits the number of systems where this method can be applied. Modern technology requires modeling on large space and time scales, and we see what do we have, we see whether we can combine it or not. Usually we cannot combine them just by taking and putting them together, because it will not work. Some connecting chains are missing, and we have to create them. Then we speak with our potential partners from the industry, explain what we can do. In most cases they say that, well, we are satisfied, let's try. And in some cases collaboration starts, etc. But again, in order to create those missing chains, we need human resources. Yeah, we need human resources, which means that we need to ask some contribution from companies.
Yeah.